Okay, as a start, who can remind us that we said thermal energy can transfer by 3 different ways. Thermal energy can transfer by 3 different ways. Who can remind us of these 3 ways? Mazen?
Yes, teacher. Radiation, convection, conduction.
Radiation, convection, and conduction. Excellent, Imran. Thanks. Another one, what is the meaning of radiation? We can talk about radiation. Radiation, we can talk about radiation. Another one, Abdullah, Abdulaziz Al-Afif.
ايوه
Yes, Abdullah. What is radiation, Abdullah?
radiation
Hmm.
is the transfer of thermal energy from one material to another by electromagnetic wave.
Yes, excellent, Abdullah. Thanks. So Abdullah said it's a transfer of thermal energy from one material to another material. So pay attention here, we have 2 materials. We have 2 materials, like sun and earth. Okay? And then the transfer of energy from the sun to the earth by electromagnetic waves. So now in radiation, conduction, convection, all of them are the transfer of energy. Okay. Between 2 materials in radiation, we have 2 materials, okay? And this transfer does not need medium, okay, like space or vacuum, so it will transfer by electromagnetic waves, okay. The second one, conduction. Conduction, who can say what is conduction? Conduction. Okay, Ahmed Malki. Conduction.
Yes.
Yes, what is conduction, Ahmed?
والله أستاذ ما أعرف إيش فرق conduction وconvection.
Listen to friends. Ayman. You know conduction, Ayman?
The transfer of thermal energy from one object to another by touching.
Yes. So now the transfer of thermal energy from one material to another material, you said by touching. Okay, you are right. The 2 objects or the 2 material must be in contact. Must be in contact. Okay, and this happens by collision of the particles. Collision of the particles. Okay, excellent, excellent. We said radiation, we have 2 materials. Conduction, we have 2 materials. The 2 materials in radiation, they don't touch each other. There is no contact between the sun and the earth. So the thermal energy transferred by electromagnetic waves. But in conduction, like what you can see here in this picture or image, okay, in this picture, what you can see here the flame touches what? This metal. So it will heat the metal. So this conduction. Okay, this is what? Conduction. But if you put your hand here, you feel the heat. You feel what? The heat. There is no contact between the fire and your hand, but you feel the heat. So it is what? Radiation. So conduction and radiation, we have 2 materials. We have 2 materials. But in radiation, there is no contact between the 2 materials. In conduction, we have contact between the 2 materials. Okay? The third way we will talk about today, inshallah, is convection. Is what, Shabab? Convection. Do you know the meaning of convection in English? Do you know the meaning of convection? What is the meaning of convection from English in general? What does it mean? Mazen, do you know?
No, teacher, but sorry, did we take the page 177, hot air
Yes.
balloons and over?
Yes, yes.
We didn't highlight anything, teacher.
Okay, you can watch video again on highlight. Okay, Shabab. Do you know the meaning of convection? Hassan, what is the meaning of convection?
Yes, the act of carrying.
The act of carrying. Yes, the act of carrying. Okay, excellent. Thanks, yeah, Sam. Okay, so Shabab, the act of carrying from Latin convictio means what? The act of carrying. The act of carrying. So something is carrying another thing. Okay. So this is the meaning of convection. So in convection, okay, it said is the transfer of thermal energy like the other definitions by the movement of particles. So the particles is moved from one place to from one part of a material to another. So here, how many materials we have? We have only one material. So pay attention for this. For radiation, we have two materials. In conduction, we have also two materials. But in convection, we have only one material. So pay attention for this part. Okay? And in radiation, the two materials, there is no contact. In radiation, the two materials, they have no contact. They don't touch each other, so they transfer by electromagnetic what? Waves. In conduction, the two materials are in contact. They touch each other. Okay? So it depends on collision of the particles. Collisions of the particles. In convection, we have only one material. We have only one material. But what's happening? No. The particles itself, the particles of the one material move from one place to another place. So the particles itself move from one place to another place. The particles what? Move. The particles move. So pay attention for this difference. Yes, Osama.
Yes, Mister. Page 177, we didn't highlight anything.
Yeah, so highlight. No problem. You can ask your friends who did highlights, okay? You can make highlights. Okay, Shalom. So now we have made a comparison between the three ways of heat energy transfer. Okay, we will watch a video now about convection.
In this video, we will learn when you keep an object near a burning wood, it becomes hot because of heat transfer. In this video, we will learn about different ways in which transfer of heat can take place. Heat can be transferred from one object to other by conduction, or convection, or radiation. When heat from one object gets transferred to other object by direct contact, it is known as conduction. For example, when we make tea, heat from stove gets transferred to steel pan because of direct contact, and thus this is conduction. When you iron your clothes, heat energy gets conducted from ironed clothes. In convection method, movement of particles of liquid or gas cause transfer of heat from heat source. Let's take an example of pot of water. As we heat it, water particles near the heat source gets heated first. We know that addition of heat causes increase in movement of particles, thus these particles move randomly and a relatively empty space is formed. To fill this space, particles from far areas move here. Again, these particles acquire heat energy and move away. This process goes on and whole water becomes hot. In conduction and convection, there is a medium in which heat gets transferred. But there is no medium between sun and earth, still we get heat from it. When heat transfer takes place without any medium, it is called radiation. You must have seen people sitting around the fire. Here too, it is transferred in the form of radiation. In fact, every hot body radiates heat and becomes cold. Let's take an example of boiling water on a stove. Heat from heat source. Let's take an example.
So pay attention here. So we revise now convection and radiation. The new thing we want to consider is convection. Now the fire comes, the heat, the thermal energy comes from the fire to this pan. Okay. Then it transfers to the water. Okay. But how the thermal energy transfer from water particles, between water particles. So now we are going to talk about only the particles of water. What happens inside the particles of water? What is happening inside the water itself? Okay? What is happening here? Here you can see that these particles are down. These particles are down, so they get thermal energy by contact from the metal pan. Okay? Then when they get hotter, they move faster. When they are hotter, they move what? Faster. This is number one. Number two, they move away from each other. This means they become with less dense. Okay? At the same time, particles at the top are cold and near to each other, so it means they have high dense or high density. Okay, so when you talked before from the lesson of density that materials of high density, if we have two materials, high and low density, this material of high density will come down, okay, and the material of low density will rise up. Okay. So if we completed watching the video, you can watch the particles will get hotter and rise up, and the cold particles from up will come down. Now the particles are getting hotter, they gain thermal energy, okay? So they will now with less density, so they have to move up. The particles at the surface, they are cold, so it means they have high density, so they have to come down or to go down. Then they will be heated and they gain thermal energy, so they go up again, okay, and another particles go down, and it will continue moving like this one. Okay, so what does this mean? This means what? Convection. So convection is the transfer of thermal energy by the movement of the particles. So pay attention, here is the key. And also from one part of a material to another part. Okay, so you have only one material, Okay, so this is the meaning of convection. Right? Convection happens where he told us here convection only occurs in fluids. What is the meaning of fluids? Fluids means liquids and gases, liquids and gases. Okay. So as I said here, such as water, air, magma, and mobile sea. So where convection happens, convection only occurs in fluids, liquids, and gases. Like, could it happen in solids? Convection could happen in solids. Who can answer this question? Convection could happen in solids, and why? Amazing.
No, teacher, because the solid is not fluids.
Okay, I know solids is not fluid, but what is the reason? Okay, we'll come back. Hassan, you raised your hand. You have an answer, Hassan?
Yes, Mister. I think because the particles is so close.
Yes, the particles in solid is so close and they have intermolecular forces, a strong forces that hold the particles together. In other meanings, the particles are not free to move. the particles cannot change their position or their place to move to another place. Okay, thanks, Hassan. You did well. So convection happens only in fluids, liquids, and gases. Why? Because the particles are free to move. But in solids cannot happen because the particles cannot change or cannot move. Okay, so this is the meaning of convection. Okay, and we said why this happens? Because the particles down becomes with less dense, so they rise up. Another particles from up with high dense, they will come down because they has more or have more density. Now we want to read these paragraphs and watch videos about convection in our life. We'll choose some guys who are not sharing at all. Wissam Muhammad. Wissam Muhammad.
Hey, what's up?
Yes, you are eating or what?
Yes.
Yes, you are in a period now, my class. Okay, read.
From where?
From here, from the
Density?
beginning.
When you heat a pan of water on the stove. دقيقة.
The burner?
The burner heats the pan by conduction. This process shown in Figure 12 involves the movement of thermal energy within a fluid. The particles that make up liquids and gases move around easily. As they move, they transfer thermal energy from one location to another. Convection is the transfer of thermal energy by the movement of particles from one part of a material to another. Convection only occurs in fluids such as water, air, magma, and maple syrup.
Yes, so you can highlight these 3 lines. Okay, now we move to another part. Now, density, thermal expansion, and thermal contraction. We can read this part. Which one will you choose? Which one? Shabab, there is some guys enter the room, then they leave. Okay? You are not accounted to be inside the class. You have to attend the class from the beginning to the last. So it means 1 guy or 2 guys enter and leave, so they are absent. I'll take only the attendance in front of me. Ayman Ishaq. Ayman.
Yes,
Yes, can you read please?
in Figure 12,
Yes.
density, thermal expansion, and thermal contraction. In Figure 12, the burner transfers thermal energy to the beaker, which transfers thermal energy to the water. Thermal expansion occurs in water nearest the bottom of the beaker. Heating increases the water's volume, making it less dense.
Yes, continue.
At the same time, water molecules at the water's surface transfer thermal energy to the air. This causes cooling and thermal contraction of the water on the surface. The denser water at the surface sinks to the bottom, forcing the less dense water upward. This cycle continues until all the water in the beaker is at the same temperature.
Yes, this process, as we said before, the transfer of thermal energy will continue until we have the same temperature. So now we are talking about the same material. So the whole particles have the same kinetic energy or have the same temperature. So this will stop. So what we saw here is a current of water going up and another current coming down. So we call them convection currents. We call them what? Convection currents. So as you can see here, what is the meaning of convection currents? Now, the movement of fluids in a cycle because of convection is called what? Convection current. So these currents makes what? A cycle. Makes what? A cycle. They continue to move like this one. They are forming what? Cycles. Okay, so we call them convection currents. Now the other part, does this convection currents happens in our daily life? Yes, we have many examples here in this paragraph. They give us different examples about convection currents. Convection currents circulate the water in the oceans. Okay, in oceans, inside the oceans, we have convection currents that they can move oxygen between the water and make the current water to move water from a place or from ocean to river or from to sea and from sea to the river or opposite. So they are what convection currents. They also circulate air in your room. Okay, also inside them, inside the earth or surface, we have layers of earth. We have the core, we have mantle, we have the crust. Also, the material inside the earth, they are liquids, so they have convection currents inside our earth. And this, when we have a huge convection currents, we could have an earthquake. Okay. Also, they move matter and thermal energy from inside the sun. The energy from the sun, it comes from inside. So convection transfers this one from inside to the surface of the sun. Okay, so these are different examples. Also on Earth, on the surface of the Earth, convection currents move air between the equator, okay, near to north 30 degree and near to south. And this plays an important role in our climates. Okay, so here we have to know only what's the meaning of convection current. Okay, and this causes many phenomena in our daily life, like what's happening inside Earth or our atmosphere, inside your room, what moves the air, convection currents. We can watch now a good video for this one, for convection currents. This is happening inside Earth, but you can see first this one, then watch the other one.
Things you'll never see in a science class. Have you heard the heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. Take a deep breath. Get ready for one of the most hypnotic things you'll ever see in a science class. Have you heard the heat rises? Well, here you can see it's true for yourself. I've got some food coloring on the bottom of a plastic container, and there's a hot mug right underneath the red food coloring. As it's heated, the water rises. But I want you to look closely and notice something else. The blue on the sides is being drawn in. You can see it better when I speed it up. Here's the thing I want you to remember. When water moves from one place, it doesn't leave a void behind. Water from somewhere else has to move in to take its place. That's why you can see the blue food coloring coming in from the sides. You can see it better from above. Watch that blue food coloring get drawn in. Do you see it? The hot water reaches the top, and then it gets pushed toward the edges by more hot water rising from underneath it. As it goes out to the edges, it starts to get cool, and cool water sinks just as hot water rises. And if you watch really carefully, you can see it sink and get drawn back toward the middle. These are called convection currents, and you see them moving here in two big ovals. They're one of the major things that drive ocean currents, especially in the deep oceans. But it's not hot water rising that drives the ocean currents. It's really cold water sinking up near the poles. Here's a piece of ice that I froze with some blue food coloring in it. so you can see how cold water sinks. As water sinks at the North Pole, for example, water has to flow up from southern regions to take its place. And these currents travel around the globe, some of them taking 1,000 years to complete their course. Understanding convection currents will help you get a grip on weather systems and the movement of Earth's continents over the eons, and even the workings of a lava lamp. If you want to try this for yourself, click on this link for all the directions you'll need. Thanks for watching.
I hope this video was a good one to explain convection. Now you can see convection inside our Earth.
Because hot rock rises, that ultimately causes the continents to move. The remarkable cycle is complete.
Okay, guys, so we have seen here different live phenomena about convection currents. It happens all over our world, inside the Earth, up on its surface. It is responsible for the movement of wind, okay, rain, inside your room, the movement of air inside your room, the movement of air between two places on Earth, okay, inside oceans, okay, all of these are because of convection currents, okay. Now we reach